Assalamualaikum and hi everyone. We are from Group 1. So our topic is about preventive and evaluative frameworks in a safety and hazard analysis. Safety and hazard analysis, the critical part of occupational safety and health, focusing on identifying, evaluating, and controlling workplace risks before accidents occur. While preventive and evaluative frameworks in occupational safety refer to systematic methods used to identify, assess, and control workplace hazards before accidents occur. There are three key frameworks in this topic. The first one is Job Safety Analysis, JSA, or Job Hazard Analysis, JHA, will be used for identify hazards in each step of the job. And the second one is risk matrix evaluation that will be used to measure risk based on likelihood and severity. And the last one is bow tie method, which is visualize causes, hazards, and consequences with control measures. Early safety management was reactive, focusing on actions after accidents occur. But during the industrial era, which is in early 1900s, accidents increased due to machinery and unsafe conditions. Thus, over time, safety evolved into a proactive approach, focusing on prevention. During 1930s to 1950s, the introduction of systematic safety procedure, which is in the early GSE concept, and then 1970s, the establishment of safety regulation like the Occupational Safety and Health Administration, OSHA, and then 1980s to 1990, development of formal risk assessment tools like risk matrix, and then 2000s until present, advanced models like the bow-tie method are used in high-risk industries such as oil, gas, and aviation. Thus, today, these frameworks are essential in achieving zero accidents goals and compliance with the international standards like ISO. Next, I will explain the importance of these frameworks in occupational safety and health. First one, these frameworks help prevent workplace accidents by identifying hazards before incidents occur. Organization can reduce injuries, fatalities, and even equipment damage. This makes the workplace much safer for everyone. Second one, they help improve risk decision making. For example, the risk matrix allow us to prioritize risks based on their severity and likelihood. High risk situations require immediate action, while low risk situations can be monitored over time. Third one, these methods enhance worker awareness. Tools like job safety analysis involve workers directly in identifying hazards. This is not only improves safety, but also helps build a strong safety culture within the organization. The fourth one, they provide clear visual understanding. The bow tie method, for instance, clearly shows the causes on the left side, the consequences on the right side, and the control measures in the between. This makes complex risks easier to understand, which this all method will be explained to the next topic. Finally, these frameworks ensure legal compliance. They are required by safety authorities such as Department of Occupational Safety and Health Malaysia. By following these methods, organization can avoid penalties and legal issues. Overall, these frameworks play an important role in creating a safer, more efficient, and legally compliant working environment.
Hello everyone, I'm Joe. I'm responsible for the methodology part. Our main goal is to find, check, and control hazards before accidents happen. This helps us keep work safe and avoid dangers. We want to build a safety-first culture in the workplace. We use these frameworks in daily work to manage risks earlier. This helps all workers and teams stay safe at work. Mm, we use three simple and useful methods for safety analysis. The first one is JSHHA. It helps us find and control dangers in every job step. The second one is risk matrix. It helps us rank risks and use resources in the right way. The third one is Botti method. It shows all risks and safety controls in a clear picture. First, let's talk about JSAGG. It's a simple way to divide the job into small steps. We find the possible dangers and use safe rules to control them. It can stop injuries and sickness at work, and it also improves safety rules and trains workers. Mm, it makes us follow safety laws easily. The best part is it's easy to use and let workers join in. We can say JSA is the base of a good safety culture. JSA has five clear steps. Step 1. Choose high-risk new and change jobs. Step 2. Break the job into clear and easy steps. And step 3. Find what can go wrong at each step. And step 4. Use controls, remove danger, change it, or use PPE. And step 5. Train workers and check the plan regularly. Our goal is to stop accidents before they happen. Now we introduce the risk matrix. It's a clear tool to check two things: possibility and seriousness. It helps us rank risks and focus on important problems. It makes assessments fair and helps us make quick decisions. It is not just a calculating tool, it's a bridge to talk about risks and with all team members. Everyone can understand the risk level and how urgent it is. The risk matrix has two key parts. First, seriousness, from 1 small to 5 very serious. Second, possibility, from A rare to E very often. We use four colors to mark risks: green, yellow, orange, and red. By putting risks in a matrix, we can see risk clearly and decide fast. Now we talk about the Botti method. It was made by Royal Dutch Shell in the 1990s. It's a clear picture to show risk reasons, accidents, results, and safety barriers. It is easy to understand and show the full risk story. It finds control problems and makes risk communication better. It helps us manage risks earlier and avoid big accidents. The body has three main parts. Left side, threats and prevention barriers to stop accidents. Middle, top events, which is accidents itself. Right side, mitigation, barriers, and the results to reduce harm. The key logic is stop accidents first and reduce harm if they happen. Let's compare the three methods. GSA is best for job steps, easy to use and clear enough. Risk matrix is best for ranking risks, very clear to see. Booty is best for complex systems with the clearest picture. We choose methods based on work needs and system difficulty. The three methods work together very well. GSA finds dangerous risk matrix ranks them, Booty shows the full system. To use them well, we follow 5 steps: choose the right method, let people join, write down results and train workers, check regularly, and keep improving safety rules. Finally, there are our main points. Prevention is better than fixing problems after accidents. Clear tools make safety communication easier. A structured way reduces human mistakes. Worker participation is very important. Clear communication can really save lives. So this is the end of my methodology. Thank you for listening.
Hello everyone, this is Mohammed and I will proceed section 3 in our presentation and the topic detailed discussion. The subtitle for this topic is Job Safety Analysis, Job Hazards Analysis, Risk Matrix Evaluation and BOTA Method. And they will present by me and Lesemai. And now here, an introduction for job safety analysis and job hazard analysis. So it's also known job safety analysis, also known as G hazard analysis, is systematically a technique focusing on individual job task, breaking each into sequential steps to identify hazards before they occur. This technique is developed in 1940s by U.S. Department of Labor standards under OSHA 1371 and revised 2002. This technique are widely adopted in oil, gas, construction, manufacturing, utilities, and healthcare. And the principle for this technique, first breaking every job into steps, then identify hazards, after that define controls. And we conduct this technique before starting a new or non-routine task, after near miss, accident, or an accident, when COP need to be updated, high risk task, engineer a solution, height, chemicals, heavy machinery, and boarding new workers to hazard task. Priority, high frequent, and high severity potential. For job safety analysis step, it's include 4 steps. Select the job, choose task. The second break into sequential step, list each basic step in sequence. The third step is identify hazard by step. What could injury the worker, damage equipment, and number 4, develop preventive control, apply hierarchy control. And in this page, I will explain what hierarchy of controls element mean. So for elimination, it's remove the hazard entirely from the process. Substation replace with a less hazardous alternative, and engineering controls, guards, interlocks, local access, ventilation, administrative controls, COP training program, worker payments. And for personal protective equipment like golf, safety goggles, and helmet, and so on. For job safety analysis worksheet, high pressure line maintenance. An example, isolate the line. The potential hazard for this job, residual pressure release, verify association with pressure gauge, LO2O procedures mandatory. For this is recommend for prevent action, and for drying the line, the potential hazard is chemical exposure, and to recommend for prevent this action is chemical resistance glove and face shield, approved drying point only. And for disconnect fling bolt filler under load, calibrated torque range, personal clear and flank face. In this page, we will discuss the just safety analysis, just hazard analysis, strength, limitation, and industry use. For strength, simple and cost effective, no specialized software need, inch for frontline workers with base task knowledge, create documented safety record for regulatory compliance, applicable across all industries and scale level, effective training and induction tool for new employees. The limitation is limited to single task, does not capture system-wide risk, high, highly dependent on analysis experience and scale, can degrade into compliance exercise if not enforced, does not model interactions between concurrent tasks and industry and Malaysia regulatory context, oil, gas, BTWI system at Petronas, Shell, AXON, mobile, construction, elevated work, excavation, hot work, confidence space, entire, and for healthcare, utilities, example, patient handling, shared management, and for Malaysian context, OSHA 1994 and DOSHA Malaysia HIRC guidelines. After job safety analysis, we move to the second step by risk matrix evaluation. The risk score formal uh, is equal likelihood time consequence, a visual decision making tool that evaluate and priority identify hazards by assessing the likelihood of occurrence and severity of consequence. Or the likelihood scale will be from 1 to 5, depending on the level of likelihood, starting with the rare, may occur only in exceptional circumstance, unlikely, could occur but not expected, possible, may occur at some time, unlikely will probably occur in most circumstances, and almost certain expected to occur in the most circumstances, and for consequence scale also from 5, starting with an insignificant, no injury, minimal financial loss, and then minimal first aid treatment, moderate medical treatment required, and then major at the number 4, extensive injuries, loss of production capability, and catastrophic death of or permanent disability. Major environment uh, damage is the in this level. So the standard for risk matrix will be present as numbers from 1 to 25, depending on the severity and likelihood. From 1 to 4 is monitor, and from 5 to 9, this is medium, and we need speed manage. From 10 to 16, urgent action required, and critical from 17 to 25 to stop the work immediately. And how to use the risk matrix. And to answer this question, there's a step should be a step application of the risk matrix. First one, list identified hazard from job safety analysis or site inspection. Assign likelihood score from 1 to 5 based on historical data or engineering engagement. Assign consequence score from 1 to 5 based on potential outcome severity. Calculate then risk score by, by likelihood times consequence and plot on the matrix. Determine the risk bind and required action level. Implement control and rescore the determine residual risk at the last step. This page will present a case study for chemical storage faculty. An example, chemical spill, fire from ignition source, manual handling, slip, on wet floor toxic gas release. We found the higher score was chemical spills and need action secondary containment bound required.
For the last risk assessment method that will be explained in this presentation is the bow tie method, where it is a visual risk analysis technique that maps out root causes and also the event they cause, together with the consequences and prevention and mitigation barriers at every stage of it. A bow tie diagram usually is portrayed by the shape of a bow tie, according to its name, and they have a few key components. Usually, a bow tie diagram is separated into three parts, which are the left part, the center part, and the right part. For the left part, they are composed of the components threats and prevention. With threats, we define what are the potential causes that might cause a hazardous event to happen. And the prevention includes barriers that can control these causes to cause the event from happening. However, for the right part, they are usually composed of recovery and consequences components. Where for recovery, we define what are the mitigation barriers that could minimize the severity of the consequences after the event happened. So for the recovery part, we minimize the potential outcome that might happen. These are a more detailed explanation of each of the components, where the threats are the root causes of the events, and together they have the prevention barriers that can control the threats from happening. The center part is the event where the hazard is released, and then for the right part, there are consequences and mitigation barriers. Consequences are the outcomes that occur if these mitigation barriers fail. And for the last part, there is also escalation factors that can sever the barriers, defeat the barriers' effectiveness. An example of case study for this bow tie diagram is high pressure gas line rupture, where the top event is loss of containment of gas, which will result in high pressure gas release. For the left side, which includes the threat and prevention barrier, for the threat, there are a few causes that might cause high pressure gas release. For example, corrosion of pipe wall, mechanical impact from vehicle, seal or gasket failure, operator error during isolation, and overpressure event. And for each of these threats, they have their own prevention barrier. For example, corrosion of pipe wall. To prevent this, we could implement regular pigging and corrosion inspection program. Mechanical impact from vehicle, we could prevent this from vehicle exclusion by implementing vehicle exclusion zone and also physical crash barriers. However, each of these barriers, they have their own weakness, which are defined by escalation factors. For example, regular pigging and corrosion inspection program, they have a weakness where inspection might not be conducted on schedule. For example, for the threat of overpressure event, we might prevent this by implementing pressure safety valve. However, there might be a weakness where the PSV is not calibrated or even stuck in closed position. And then on the right side, which includes consequences and mitigation barriers, the consequence of high pressure gas release from happening is there are several of them, but some of them might include fire or explosion, personal injury or fatality, and also environmental contamination. And there are mitigation barriers from to minimize the severity of these consequences. For example, from minimizing fire or explosion, we can implement gas detection system and also emergency shutdown. For preventing personal injury or fatality, there could be an ERP and master point. And for environmental contamination, we could implement containment bond and also emergency flare system. However, each of these barriers, they have their own weaknesses. For example, for ERP might not be drilled or even master point might be unclear for the stuff to follow. For gas detection system, for example, the detector might be offline or the emergency shutdown system is not periodically tested. For the key lesson, the bow tie method forces analysts to think not just what the barriers that we have, but also what could make these barriers fail. For a comparative summary of all three methods, for JSA, they focus on single tasks. Risk metrics focus on overall risk ranking, and bow tie method, they focus on the full causal chain from the cause to the consequence. Output for JSA is a step-by-step hazard table. For risk metrics is risk score and priority list, and for bow tie method is a visual bow tie diagram. JSA best used for routine and non-routine tasks. Risk metrics is to prioritize all identified hazards, and bow tie method is for complex, high-consequence scenarios. JSA don't really need very high skill. Low or medium is enough. Risk metrics low skill is also enough. For bow tie method, because it studies the full causal chain of an event, we need medium to high skill. Standard for JSA is OSHA 3071. For risk metrics are ISO 31000 and AS and NZS 4360. And for bow tie method, the standards are IEC 61025 and Shell DP. For industry use, JSA and risk metrics are suitable for all industries, but bow tie method, they are more suitable for oil and gas, aviation, and nuclear. So for statement, these three tools are not alternatives. They are actually complementing each other to compose a complete safety analysis system. How? Because JSA or JHA, they identify what the hazard is. Risk metrics, they determine how urgent the hazard is. And bow tie method, it reveals how can the hazardous event happen and how it can be controlled at every stage. And by using this together, they form a robust, defensible, and legally compliant hazard management framework.
So we will now move on to conclusion of this assignment. This conclusion will be divided into three parts, mainly the key points we've identified for each tools. Then we'll see how they impact workplace safety, and then how they impact risk management. We'll conclude this study case by our final thoughts on the matter. So, firstly, key points identified. So as we discussed, there are three main tools. We had job safety analysis, risk metrics, and bow tie. Each one of their individual works, such as job safety, is a single task analysis tool that is used to break down tasks and to identify specific hazards and identify specific processes. It can be used on multiple times on the same task to identify multiple problems. Risk matrix is a tool that is used to evaluate risk or likelihood times severity. So to assess each risk, you need to attribute them a score for each situation. Then you can prioritize risk elimination according to the score that you received. The last one is bow tie. Bow tie is a diagram that helps us to have a visual representation and then identify causes and effects for each hazardous situation. And with that, we can have a visual control measure. They're not only individual tools, but they work together, such as GSA is the identification part where you can identify your issues, hazard, problem, risk. Risk matrix is where you evaluate them to prioritize, and then bow tie is the control part. Workplace safety. How can all of these tools impact workplace safety? We've used this temple representation to help us understand. So the first layer is safety culture training communication. Then we have the pillars, which are 3 tools. We have this as pillar because if you take one out, the whole can crumble. Because they have their individual limitations. So we need the 3 of them to work together. GSF, for example, is too specific. It can overlook outside interaction if not used properly. Risk matrix can be biased by subjective score attribution by the one who builds the matrix. And the bow tie takes a long process, so you need the good risk assessment and evaluation to work on the precise and most important risk. So these tools are complementary and they help us identify, evaluate, and control risk. This system can address the complexity of workplace safety by having a structured reflection, highlighting risk, and considering every aspect of risks. As for risk management, which is at the top part of the temple, it's only able to exist once a safe workplace is in place. Why? Because you cannot do management if there is still existing problem. You first need to solve this problem. So once our risk management is in place, we can do a strategic decision making, mainly going from reactive safety to proactive prevention. Also, we can standardize safety practice, invest in safety measure, and increase. This also means an increased safety, which can lead to operational reliability and higher protection. Our final thought on the matter is that the process which use preventive and evaluative framework tools is mainly the risk elimination, which can lead to workplace safety. And then we can put in place risk management, which can be used to have preemptive risk elimination. So as I said, before preventive evaluation framework tools, we were reacting to risk. We had a limited visibility on complex risk, higher number of accident incidents, lack of risk realization. Then after the use of preventive and evaluative framework tools, we had clear hazard identification, structural evaluation, risk control measure implementation, and less accident and incident. Thank you for your time, and we are open to any question.